There we go. Okay, so your bell work was to write these words and to circle the words that you don't know. All these terms are in our lesson today. I wanted you to write what you think they mean, and then as the lesson progresses or when you go home tonight, revisit these and correct if you need to or add to. So I ask you to leave a little space, and we've had a few minutes. So with that, I'm going to move on now. Here's some of the terms right up front. So measures of central tendency. You're going to hear that term, central tendency, a lot. Measures a central tendency. So we know that central tendency is going to measure something in the center of something, right? In tendency, think about what the word tend means, to tend something. Okay, so tend to the children, tend to your homework, work on it, right? So we've got some measures here of the central tendency. 3 of the measures of central tendency that we're going to work with in this lesson is mean, median, and mode. So the mean is just the average. You've seen that. You've done it since you were elementary school. You've taken an average of things. You're going to take the number of elements and their values and divide it by the number of elements. So it's the sum of the data values over the number of data values. So if I've got this data set 1, 2, 3, 4, 1, 2, 3, 3, 4, 5, 5, 9, if that's my data set, then I'm going to add all of these together and divide it by the number of terms. So 1, 2, 3, 4, 5, 6, 7, 8. I've got 8 items here. So I'm going to sum 1 plus 2 plus 3 plus 3 plus 4 plus 5 plus 5 plus 9. And I'm going to divide that by 8. And when I take that, I get a 4. So I can say that the mean, which you've also used interchangeably with average, the average of these items are 4. You're going to see this also denoted as X bar. Okay, when you see this sign, capital X with the bar over it, that also means mean. Okay, median is the next measure of central tendency. So it's put everything in order from least to greatest and then start knocking out each end. Keep moving inwards till you get to the absolute center. Well, here I had an even number of items, so my absolute center is 3 and 4. In that case, I'm just going to take the average between 3 and 4, so add 3 plus 4 divided by 2. So 7 divided by 2 is 3.5. So I can say my median for this set of data is 3.5. Okay. When it's an odd number of items, then it's just the absolute middle item. In mode, our last measure of central tendency, it's the most frequently occurring value. So let's look at our data set again up here. So we only had one of those. We had 2 of these, 1 and 2 of those, and 1 of those. So it looks like we've got a tie for our mode between 3 and 5. So we can say 3 and 5 are our mode. If we had had 3 number 3s, then 3 would be our mode. If I had 6 number 5s, then it would be the mode. Whatever occurs the most, that's your mode. Any questions over this? Okay. In our first problem, we're going to find some measures of central tendency. It says this frequency table shows the number of job offers received by each student within 2 months of graduating with a mathematics degree from a small college. Long sentence. What are the mean, the median, and the mode for the job offers per student? So job offers per student. What are the mean of the job offers per student? So when we look at this, we're going to take all the job offers. So we know we had 2 students had 0 job offers. So that's going to be a 0 and a 0. And then 2 students had 1 job offer. So 1 and 1. 4 students had 2 job offers. 2 and 2. And 5 students had 3 job offers. 1, 2, 3, 4, 5. And 2 students had 4 job offers. 1, 2. So there's all of our job offers per students. Now to get the mean of that, we're going to add all these together and divide it by the number of job offers. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. What did I miss?
Shouldn't it be 2 modules there?
Oh, that's where I messed it up. Thank you. I was like, I'm short 2. Thank you. Good eye. Yes, I had 4 2s here, and I had only written 2. So thank you. So now I have 15 items, right? 15 offers. So now I'm going to add all of these together and then divide by 15. Now notice when they wrote it down here, they just used multiplication. 2 times 0, 2 times 1, 4 times 2, 5 times 3, and 2 times 4. Same thing. But I wanted to display our data like you're going to be used to working with it in this assignment. So we're going to say x bar, or the mean, is equal to the sum of this divided by 15, which is 33 divided by 15, which equals 2.2. So we can say the mean, or x bar, is equal to 2.2. Any questions over that? Next, they want us to find the median. So we've got the mean. Now let's find the median. The median is the absolute middle point. So let me get a different color. So we're going to just start knocking off each end. There's one set. Knock off the next set. Knock out the next set. The next one. There. 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 And there's our absolute middle number. It's easier when it's in a straight line because you can just go boom, 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 boom with your fingers. Right? So it looks like our median is just 2. Oh, and they had it in order right there. So you'll see me do this. I'll mark them out like this. That one. And there it is till you get to the absolute middle. Okay? So the median is just the absolute middle value. The most important thing is making sure they're in order before you start. If they're not in numerical order, then you're going to have a problem. Okay, so now we need to look at what's the mode. What occurred most frequently? What did we have the most of? So let me erase all this and let's look at it. So I'm going to circle, okay, we had 2 zeros, 2 1s, 3 or 4 2s. Okay, so then those are out because now we have 4 of something. 1, 2, 3, 4, 5 3s. So now that's the highest occurring number, and 2 4s. So there was the most 3s in our data. We had 5 3s, which is the most any time any one of these appeared multiple times. The highest occurring value is 3, so 3 is our mode. Whatever occurs the most in your data, so the mode is 3. Any questions on those? All right, let's look at our workbook. Number 1 on 11.5. It says find the mean, the median, and the mode of the following data set. Well, the first thing we want to do is put it in order. So let's do that. What's our smallest occurring number here in our points? 15. What's the next smallest number? And after that, how many of those do we have? So 2 24s. Make sure you put every occurrence and multiples. And then the last is 30. So now to get the mean, we're going to add all these together and divide it by 1, 2, 3, 4, 5 items. So add 15 plus 17 plus 24 plus 24 plus 30 divided by 5. So when you add those, it's already in your workbook. It's 110 divided by 5. And what's that going to give us? 22. So that's our mean. Okay, and if you want to write that X bar over there so you're used to seeing that and recognize that to mean. To represent mean. How's that? All right. So now let's work on the median. So we're going to go, let's see, 30 goes with 15, 17 goes with 24, and then we're down to the center. And I love it when you've got an odd number of elements because it turns up just to be the absolute center element. So our median is 24. And then what's our mode? What occurs the most? 24. And that was just coincidence that they are the same. They're not always the same. Any questions about that? Okay, so tonight you will go home and work problem. Oh, well, there's not another one exactly like this. So let's learn the next problem. So we've got number 1 done. So now let's talk about what an outlier is. An outlier is a value that's substantially different from the rest of the data set. If the data is in one variable, outliers can occur at the ends. They can be misleading because they affect the measures of central tendency. So it's like you get a class that takes a test and most of them got between, say, 55 and 80. And then you get someone that had 100%. The one that's way off out here, that's an outlier. And there's ways to tell because it's not always so obvious. It's usually at either end. But how do we tell what's an outlier? Well, there's a way. And what you want to do is take all your data set and order it, put it in order from least to greatest. So it says which is an outlier for this data set, and they give us these numbers. So let's put them in order. So our smallest number here is 56. There it is. Then 59, 59, 2 of those. The next one is 2 65s. And then we have a 73 and a 98. So order your data. That's your first step. Now you want to take the difference between each pair. So 59 minus 56 is 3. 59 minus 59 is 0. 65 minus 59 is 6. 65 minus 65 is 0. 73 minus 65 is 8. And 98 minus 73 is 25. Where was the greatest difference? It was the 25 was our greatest difference, right? Because we had 3, 0, 6, 0, 8, 25. 25 is greatly different from all these. Does everyone see that? So that means that 98 here is our outlier. Right? If we leave this in when we take an average or work on our central tendencies like the mode and the median, it's going to throw all those off a few points. So these outliers you usually throw out of your data. Okay, and you'll get into that in calculus and statistics, probability and all that. But outliers, I have a few outliers in this class that I have to throw out of my overall average when I calculate like a curve for a test. I throw those that constantly get like a 98 or 100%. I throw those out and then I look where does the rest of the class fall. And so I always have a few outliers, and usually in this class. So good job. All right. Any questions on what an outlier is? Okay, so look at number 2, or excuse me, problem 4, 5, 6, 7. Excuse me? Well, give everyone a second to look at it. So it says identify the outlier in the following data set, then find the mean, the median, and the mode. So you want to put everything in order first. So I'll let you guys do that and find your outlier. So, did anybody find your outlier yet?
74.
74. Because when you take the difference, you line all these up, you get 58, 58, 60, 62, 64, 74. And you might be able just to see it by just scanning it. But like I said, it's not always that obvious. So, to do it, take the difference between them all, and you get 0, 2, 2, 2, and 10. 10 is that one that's greatly different from all these. So that means that this guy right there is our outlier, 74. Okay, now let's take the mean. So what did you guys get for the mean? Say again? 62.7 is correct. So x bar equal 62.7. What about the median?
61.
That's correct. 61. So I erased them all in order. It was what? 58, 60, and then 62. Oh, I did 58. Thank you. 58, 60, 62, 64, 74, right? Now, the median, you went from there to there, there to there, there to there. So our median fell the two center. So you're going to take the average of those two. 60 plus 62 divided by 2 is 61. So that's how you get your median. And now the mode, what occurred the most often? 58. Yes, there were two of those. Is everybody good with that? Okay, mark out number 8. You're not going to do that one. And on number 9, mark out the second set of data. Mark a line through that Oswego, New York. And then we're going to talk about this. See that I put a line through the bottom there, the Oswego, New York. All right. So let's talk about what a box and whisker plot is. Has anybody worked with box and whisker plots?
It sounds familiar.
Okay. So when we talk about a box and whisker plot, we first have to understand what a range is. A range of data is just the difference between your greatest and least values. So in our last set of data, we went from 58 to 74. So we could say the range of this set of data is 74 minus 58, right? Which is 16. So it has a range of 16. Okay? So the range for that set of data was 16. So if you ordered data from your least to greatest value, the median will divide your data into two parts. Everybody agree? If we find the middle and mark that, we've got this set and we've got this set. Well, that's what a box and whisker plot does. Is the first thing we do is put them in order. There's your least number and your greatest number. And then you find the median, and that's your middle mark. And then we have to find these things called quartiles. So we're going to divide our data into 4 parts. That means that we have to look at the left side and find the median of the left side, and then that becomes your first quartile mark, or your first quarter, which we call Q1, quartile 1. And of course the middle is our quartile 2, and we know 2 quarters is a half, right? And then we're going to do the same thing over here. We're going to take this right side, find the middle of that, and then that becomes your quartile 3, or your third quarter. Okay? So let me erase all that real quick. Boom. Okay, so these 4 parts are called quartiles. We've got quartile 1, quartile 2, which is the midway point, 2 quarters is a half, and quartile 3. So that divides it into 4 parts, 1, 2, 3, 4. Now the interquartile range is the difference between your first and your third quartile. So the interquartile range is this right there. So you've got an overall range from least to greatest, but your interquartile is just the difference in this part. And that's what we're going to draw our box with to make our box and whisker plot. So let's look. Here is what it looks like. When you divide it in half, you're going to have your second quarter, right? Your least value is called your minimum, Your greatest value is your maximum. And then you take the halfway point of this side, and that's your first quarter, and take your halfway point on this side, and that's your second quarter. Or excuse me, third quarter. Second quarter is the midpoint. So that's what this looks like. And then you draw a box connecting your first and third quartile with that median marked in the middle. And all this is against a number line that represents your data values, right? And then you'll usually see a dot or a circle on the end. Some people do bars, tiny bars. But I like the dots. I like to use dots. Okay? Now I've got a video I'm going to show. Oh boy. Let's try it one more time.
Hello, this is Mr. Edwards, and today we will be making a box and whisker plot in order to show a good way to measure central tendencies in a data sample. Now, you have learned about measures of central tendencies such as the mean or average, the median or middle value, or the mode, which values get repeated the most. Now, in this case of making the box and whisker plot, we will be concentrating mainly on the median and the median of medians, which will be quartiles, and the minimum and maximum values. Now, the first thing we're going to do in any data sample, which is a sequence of data points, is we're going to order the data from the lowest to the highest. Then we're going to find the median value, which is known as Q2. Q stands for quartile, or quarter, like the end of the second quarter is halftime in a football game. And this will be for the box. Then we find the quartiles, the first quartile and the third, which are like the end of the first quarter and the end of the third quarter. And that will be used to make up the box. Then we find the minimum value and the maximum values in the whole data set. And those will comprise the whiskers. So let's go right to the example. Here we have a series of 9 data points. These could be the grades on a test, for example, 84, 79, 90. Now, the first thing we need to do is to order the data from the lowest to the highest. So let's look at this, and I will give you time to write out the data in order from lowest to the highest.
In order, and so what's going to be first? 67. So I'm not going to spend all of our time doing this. Hopefully that you've done that so far. I'm going to continue here for sake of time.
Okay. What I'll do now is bring this over here, and let's see how we can...
Okay, so there it is. 67, 73, 79, 81, 84, 88, 90, 92, and 95. So you're going to find the median first. So you're going to take the average, right? Add all these together and divide by 9, because there's 9 elements. So that's your first step. Oh, I'm sorry. I just said that completely wrong. To find your median, you're going to start at each end and work into the middle. Sorry, I got thrown off by walking away. All right, so 90, 92. So your middle looks like it's going to be what? 84. So you go in. And the absolute middle is that fifth value.
get all the data points here. Okay, so here I've ordered them from the lowest to the highest.
The median.
67 is the low.
The median is not an average, so strike that what I said a minute ago. It's just counting from the outside inward to get to the middle value.
Lowest all the way through to 95, which is the highest. In green here I have placed the ranking. Now, the first number of 5 that we're going to determine here is the median, which is called Q2 because it is the second quarter. It's the point at which there are as many data points above as there are below. If we notice that there are 9 data points here, the fifth one here is 84. Notice that there are 4 data points below and 4 data points above, so that the median, or Q2, is 84. Okay, now let's look at Q1. Q1 is going to be the median for the lower half of numbers, whereas Q3 will be the median for the higher half. So this is like, let's find the median of these 4 numbers. First, we eliminate the median itself. We have 4 numbers here. So we notice that the median should happen in there, but notice that there is not a number in between 73 and 79. But when that is the case, what we do is just take the mean or average of these 2 adjacent values. So the average of 73 and 79 will be 76, and that will be the value for Q1. Over here we have something similar, 88, 90, 92, 95. The median value should be somewhere in the middle here, but there is no single number because it's an even number of data points. So we take the average between 90 and 92, and that will, of course, be 91. So now we do have 3 of the 5 numbers that we're looking for. The final 2 will be, of course, the minimum value, and here we can see that that's number 67, and the maximum value, which is 95. So these are the 5 numbers that we need, and first we're going to be putting them on a number line. Here, notice 67 as the minimum. All right, this will be the minimum point here. Q1 will be 76 into the first quarter. 84 is the median, or Q2. 91 is Q3. And 95 is the maximum. Now, the box and whisker plot is just simply a diagram that we're going to be using to show where the box is really one line we put here at the median, another line here at Q1, and another line at Q3, and we just simply make a box there. The whiskers are just going to be the line from the Q3 to the maximum as one whisker, and the other one is Q1 to the minimum.
Okay, I'm going to stop there for time's sake, and that's your box and whisker plot. Okay, remember it's against a number line. Get this back on. So let's look at our assignment. Look at number 9 in your workbook. So I ask you to scribble this line out. We're just going to change the directions here. And instead of compare the following sets of data, I want you just to write make a box and whisker plot for number 9. Okay, so, and we're doing it on this line right here, the Buffalo, New York. So the first thing we want to do is put everything in order. So look for, the way I do this when I'm working on paper is I look for my smallest set of values, and it looks like it's going to be in the 20s. So I've got a 28, and that's all. So I'm going to write my 28 down here and mark that out. Next, I've got my 30s. So I've got a 30, a 30, and a 30. There's my 30s. So I've got 33, 34, 38. So those are my next three numbers, 33, 34, 38. Okay. Now look at my 40s. I've got a 46 and a 44, and that's it. So I'm going to do 44, 46. Now I'm going to scan for my 50s. I've got a 56 and a 50. Okay, so it's going to be 50, 56. And then it leaves me with my 60s. So I've got a 61 and a 65. And then 70, 72. There, I've accounted for every number. And I like to do that to make sure I got everything. All right, so here they all are. Now let's get our median. That's the first thing. And you might want to start a number line. It's up to you. Sometimes I like to look at my data a little bit and decide how I'm going to do a number line. I generated this, so I just generate it from the least to the greatest. So mine goes from 28 by 2s all the way to 72. They'd be a little time consuming on paper. So you might want to go by 5s and just start at 25. And then you're going to mark your data points above the point or below the point. So your minimum's right there. You know that's going to be your 28. And your maximum up here is 72. Right? So you might have them in tens. You might have a 20, 40, 60, 80. Or 20, 30, 40, 50, 60, 70. Or you'd have to go to 80 because you've got a 72. So you decide how you're going to do your number line. But if you don't put your number line down there, it's wrong. Box and whisker plots must have a number line. All right, so next we're going to find our median. So here I've marked them. Let me get a highlighter. All right, so we're going to go 28 to 72, 33 to 70, 34 to 65, 61 to 38, 44 to 56, and then our two middle points is 46 and 50. All right, so we've got 46 and 50. So we're going to take the average of those two middle points. So when you add those together and divide them by 2, you're going to get 48. So mark your middle line, your median, at 48. Let me see. 46 plus 50 is going to be 96 divided by 2, which is going to be 48. Did you add 46 plus 50 divided by 2? And it gave you 47.5?
Our calculators probably did this.
Okay, make sure when you do this, do 46 plus 50 and press enter, and then go answer divided by 2, okay? And be sure to clear your data values, or clear your calculator out before you start. So it's 48. Also, you can see 46, 47, 48, 49, 50, right? You could do that as well. It's the absolute center between those two. So we've got the median. Now we've got to divide this in half and do this side. So we're going to go there, there, and now the difference between 61 and 65 is 4, and 4 divided by 2 is 2. You could do it that way too. So the median would be 63. Right, of that data set. So there's your quartile 3. You could also add 61 plus 65 and divide by 2. So that's going to be a 63. And that's your Q3. And now let's go get our first quartile. So again, over here, you're going to go 46, 28, 33, 44. So the difference between 34 and 38 is 4. 4 divided by 2 is 2. 34 plus 2 is 36. But I don't have this at 36. I got it at 35. So what did I do? 60, 72 divided. Yeah, it's just displayed wrong. I need to move that down a little. Sorry. There you go. All right. So there you go, 36, and there's my first quartile. And now you're going to draw your box. You had your bar and your middle bar, so you draw your box around your bars, and then draw your whiskers to each minimum and maximum. And that's how you do a box and whisker plot. Okay, any questions about that? All right, so on the back page of your homework, you'll do a box and whisker plot for 10 and 11. Okay, and that'll be homework. All right, 10 and 11. Be sure that you put everything in order first. All right, now let's look at the last thing, finding a percentile. And every time I put a shade on here, it's locked up, so I'm not going to do the shade again. So it says, here's an ordered list. We're going to find our percentiles now. Here's an ordered list of midterm test scores for a Spanish class. What is the value at the 65th percentile? So when we look at this data set right here, they are in order from least to greatest. How many items do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We've got 20 items. So to find the 65th percentile of these 20 items, we're going to take the number of items times the 65th percent, which is 20 times 0.65, right? Which is equal to 13. So the 13th item, actually that's not our answer, it's the 13th item. So we need to go to the 13th item. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So our 65th percentile is 82. Everybody see that? So 13 values fall at or below 82. 65% of the people got 82 or below. Any questions about that? How about the 55th percentile? What would our 55th percentile be here? So you're going to have 20 times 0.55, which is what? $11. So go to your 11th element. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you're going to say 79. So 55% of the people was at 79 or less. How about the 95th percentile? You're going to go 20 times 0.95, which is 19. So let's see, if that was 11, 12, 13, 14, 15, 16, 17, 18, 19, so 98%. Okay? So everybody see how to do those? So you're going to work the last 12 through 17 just like that and mark out 18 and 19. All right? Don't do 18 and 19. But you're going to do everything on this assignment but 8, 18, and 19. So again, how many items do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Again, there's 20 items. Make sure they're in order, and they are already in order. So now to get your 45th percentile, what are we going to do? 20 times 0.45. And what's that going to equal? 9. So we're going to go the ninth element. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's equal to 34.
I have a question.
Yes.
It gives you 16 twice, and you said make a number line, so do we just leave 16 as 1 point?
No, 16, you represent 16. If it's listed in there twice, I'm trying to look for where is number 10. Yeah, you have to use it twice. It's got to be represented twice. Okay, her question was on number 10. Before I hop back, were there any other questions on the percentiles? All right, so let's go back to number 10 where the question was. The question was, she noticed 16 was in here twice. Do you keep it in your data? Absolutely. That's what stretches or shrinks your boxes. Right? So you're going to start with, whoops, no, there's a 12. And then a 15. Let's see, we've got 19. I'm looking for all my ones. All right. So we've got 15, and then 16, 16, 17, 18, 19. So those would be represented like that, and then 20, 22, 24. Okay, so yeah, you've got to represent every occurrence of everything that appears in your data. This is due Monday, thank you, and that concludes our video.